just back up a little bit. A transformation is any type of way to change a figure. So a figure could be a shape. It could just be like a line. If you were in Algebra 2, we talk about transformations of functions, and that's what this is kind of getting us ready for, is transforming functions here when we get into Algebra 2. So transformation is just any type of change. And the changes we're looking at are slides. That's what section 9.1 is about. We're looking at flips, which are those reflections. And then we are looking at enlargements and reductions. We'll do that later on. And let's see, slides, flips, and rotations. So in section 3, we will look at rotation, so turning a shape. A couple of vocab things. A pre-image. A pre-image is the figure before you change it. So pre-image, if it's labeled pre-image, you'll see the word pre-image. But usually a pre-image is just labeled with letters, just plain letters like A, B, C, D. Then the image is going to be labeled with what's called a prime. So A prime, B prime, C prime, D prime. That tells you, that communicates to you if there is no word image anywhere or pre-image, so you don't know which one is which. The primes are going to signify where the figure is after the transformation. So after the transformation, we'll use those primes. Other things, the word isometry just means that they're congruent to what they were. So this one is going to be yes, yes, and this one is no because it changes shape. So if it's not congruent, then there is no isometry. So isometry is just when you transform it, is the pre-image and image congruent to each other. And isometry only is going to happen when you have slides, flips, or turns. And that's what we're talking about in our first 3 sections. Now, in section 1, we focus in on translations. And when we're working with translations, we're given what's called a rule. And this is our rule right here. So our rule is x plus 3 and y plus 2. So what this means is, it means take the pre-image points, x and y, and on the image point, we're going to take the x coordinate, add 3, and on the y coordinate, we're going to add 2. So that's what this rule is telling us to do. It also communicates which direction our image is going to be from where the pre-image is. So plus 3 on the x-axis, if you think about how the x-axis works, as you go to the right, that's increasing. As you go to the left, that would be decreasing. So an add 3 also is going to mean we're going to move this to the right 3. And an add 2 on the y, anytime you're going up, your y's are increasing. When you're going down, your y's are decreasing. That's going to mean that we are going up 2. So those x plus 3, y plus 2, they're telling us what to do to the x and y coordinate, but it's also communicating to us, hey, a plus 3 on my x-axis means move that to the right 3, or I guess if you're looking at me, move that way 3. Up 2 is going to mean you're moving your figure up 2. So we're going to take each of our points and we are going to move it to the right 3, and we're going to move it up 2. So it's important to remember that translations are isometry. So isometry means that they are going to be the exact same shape, just each point moved the same amount in the same direction to create your new shape. So there would be my A prime going to the right 3 up 2. B prime, I'm going to the right 3 up 2. And C prime, I'm going to the right 3, 1, 2, 3, up 2. There's going to be my new figure, now all moved the same direction, the same amount. And then we can connect, and if you don't have a color coordination, that's where we're using those primes. So the primes will signify that the A prime, B prime, C prime, that's the figure after you've moved it to the right 3 and up 2. So there would be how we can graph a translation. So that translation rule, then you can start to apply that down to other problems. So here we've got a pre-image of A and B. They're giving us the translation. Here we don't have a graph to use, but we can just follow the rule. So it says take the pre-image point. Let's just say we're using pre-image point A, -3, 5. And we want to move it to a +5 and then a y -1. So that would be taking your -3 + 5 and taking your y coordinate, which is 5, and then subtracting 1. Now, you don't need to show all this work like I am, but you can probably do that in your head. But there would be your image point. So your A prime is going to be at 2, 4. So we're going to move the x coordinate to the right 5. We're going to move the y coordinate down 1 technically, which would bring me to 2, 4. So that's going to be our first lesson in a nutshell, just looking at how we can graph translations. Our second lesson, we start to look at reflections. So we'll do 1 through 4 here for our next problem. And reflections use what's called a line of reflection. Myself, I think of it as a mirror. So it's like a mirror that is kind of the separation point between your image and pre-image. So in this first one, we're looking at reflecting S across the y-axis. So the y-axis is, let me make that so it sticks out hopefully a little bit more. Let's get a little bit more of a cyan color. So here we can go kind of draw that line of reflection. So this line of reflection acts like a mirror. And technically I wanted to make that perfectly straight. It's kind of hard to draw straight lines with my mouse. It kind of catches on things when I'm doing that. But anything with a reflection is going to be equidistant to your line of reflection or your mirror. So S you're looking at is 1 unit, 2 units, 3 units away from my mirror. When I reflect it, I'm going to reflect it equidistant on the other side. So I'm going to reflect it 1, 2, 3 units away. So here's going to be where my S prime is. So there it is. So my S prime is going to be at 3 units away from my line of reflection on the other side of that mirror. So it's very similar to how a mirror works. If you do have a straight mirror and you're standing 2 feet away from it, your image, when you look at that mirror, your image looks like it's kind of 2 feet inside the wall because your image is going to be equidistant from your pre-image. So your pre-image is you in real life, and then your image is going to be reflected 2 feet into the mirror if you're standing 2 feet away. So we're going to keep that line of reflection as equidistant to your image and pre-image points. Now the other thing, your S starts at 3, 2. And now it's going to be at -3, 2. And you'll notice when you reflect across the y-axis, your x coordinate just changes to its opposite. And then we'll take a look at reflecting across our x-axis. So when we reflect across our x-axis, that would be this line down here. And we're going to reflect V. So I look, V is 1 away, so I'm going to go 1 away on the other side. So there's where my V prime is going to be. So V prime is going to be 1, -1. And you'll start to notice when you reflect over the x-axis, your y coordinate changes to its opposite. So V did have a coordinate of 1, 1. Now V prime has 1, -1. So your y coordinate changes to its opposite. The next problems, we're going to have to go back to a little bit of Algebra 1. Reflect across the line y equals -1. Well, y equals -1 is a horizontal line where all my y coordinates are equal to -1. So that would be right there. So y equals, may want to make a little note there, is horizontal. So there would be my y equals -1. And then I want to reflect r. So I count how far is r away. R is 1, 2, 3 units away. So I'm going to reflect it 3 units away. So that's going to be right there. So my r then becomes the coordinate -1, -4. And there would be my coordinates of my new image point, -1, -4. So how we can reflect over the x and y axis, we can reflect the same if we're reflecting over a line such as y equals -1. Then our x equals equations. X equals equations will travel vertical. So y equals travels horizontal, x equals travels vertical. So x equals 2, we're going to go to where all the x coordinates are equal to 2, which is vertical. And we're going to reflect q. So we see q is 1 away. We reflect it 1 away on the other side. And our q prime then is going to be 1, -2. So there's going to be where q prime ends up. So there's how we can start to apply reflections, and then you'll look at reflecting images or figures, excuse me. So as far as like maybe a triangle or quadrilateral, we can reflect all points the exact same way. One other thing I just wanted to on your schedule, we have this Desmos app. So if you do forget, like if you're looking at it, maybe an x equals or a y equals equation. So the last one we had was x equals 2. So if you forget what x equals 2 means, open up Desmos, throw it in. X equals 2, there's where I'm talking about this line that is a vertical line where all the x coordinates are equal to 2. And then you could kind of estimate or figure out where q is, wherever that is, and then you can start doing your reflection on Desmos as well. So that's a program that we used very briefly. If you were in my class first semester, we did just a little activity, but that's going to be on your schedule. Every week you'll have that little green icon there. So you may want to check out and see some of what we're doing in class. You can kind of graph out on Desmos and kind of play around with that as well. But that brings us to 8:30. So there's just a little kind of